displays high accuracy and precision and many other performance metrics. So just part of this planning for your sensor selection, which is the question of the what pollutants are you, and what sources are you concerned about, here are some possible sources to think about. I think probably for this region, dust is an obvious one, solid fuel burning, transportation. And then for each of those sources, they have connections to which pollutants are typically associated with them. And for dust, and that might be your PM10. For your combustion processes, like your solid fuel burning, that might be all of these. All right, so the next part of the quality planning process is to think about where and when. So are you trying to monitor near a particular source? And if it's from a source that has like, a stack or something, and then the pollution comes out the stack and then it eventually is going to land somewhere and get near the ground level where people breathe, think about where might the emission plume reach ground level. Are you trying to do regional or background monitoring? Or actually, you probably should if you're trying to quantify emissions from a certain source. So let's say you have a factory that you want to say this is, they're the source of something. It's great to monitor downwind, right, and show that there's high levels, but you've also got to put some sensors upwind or at a regional or background source so you can show the difference. Like here's how much it is when it's clean, and then down here it's a lot worse. Think about prevailing wind patterns so you can know about where to site these different sensors, and the density and arrangement of the sensor network to be able to prove your point of the project goals. Will your sensors be exposed to the elements like rain or severe dust or wind? Are they going to be in remote locations? And that might mean that you have to have solar panels for them to provide reliable power. This is a hard one, right? What reference monitor co-location sites are available? In the United States, we're very lucky that that's not really an issue. We can go find anywhere nearby and co-locate sensors, but that's not the situation in a lot of places. And then what time resolution do you need? So if you have like a mobile monitoring project, like let's say you want to put sensors on a vehicle and drive around and do some measurements, you're going to need very high time resolution measurements, like maybe even every 1 second. Because in that 1 second, you've already traveled several tens of meters or something. Whereas if you're trying to do more of a regional kind of air quality study and the sensor is stationary, you could probably get away with hourly data, and that's okay. And then also, finally, what specific seasons to monitor. So for example, in the United States, we typically think about winter and summer as different kind of time regimes where low-cost sensors might perform differently. But here, it might be the dry, wet season, when the harmattan is going on and when it's not. Because then there's probably a different composition of particles that are impacting the readings of the sensors. This is just a little table of how to think about distance scales for your monitoring project. So if you're co-locating your sensors, you probably want to be within 10 meters of the reference monitor. If you're doing like, neighborhood kind of studies, but as you start expanding out to like regional scale studies, you'll be able to space your sensors out more appropriately. And then this is also a graphic to kind of illustrate the thinking about community monitoring versus source monitoring. So if you're just trying to get the information about the air pollution in a community, maybe that's something like a grid or a randomized pattern. But for source, it's very important that you have some kind of measurement upwind, so you know what the air quality is before your source or the suspected source, and then several measurements downwind of it, so you can quantify what the impact of that source is. I'm going to skip through that. That's just the Los Angeles airport. Okay. And then how? So this is a tough one. Money is often a very limiting constraint on these projects. And although it's tempting to go straight into, okay, I have this much money, let me spend it all on sensors, the reality is that maybe you should use less than a quarter of your budget on sensors. The vast majority of your funding you should probably dedicate towards the soft side of the project, the stuff that we don't think about typically, which is training staff, maintenance of the sensors, spending some money on getting training on data science or perhaps data scientists, So just make sure you don't think it's all about spending money on sensors. Another aspect is time. If you don't have a lot of time, you may not be able to actually pursue all the goals that you set out to. Again, are there any reference monitors available nearby? What kind of team do you have? And I'm going to go on the next slide about some important functions of an air monitoring team, and also what kind of skills that they need to have. So this is kind of like the different roles that would be good to have in an air monitoring team. And depending on the size of your team, you might be the only one doing all of these roles. Or maybe you have, one manager and you might have 20 field technicians, right? So, someone has to manage the project, and then you need some folks to be in the field installing, deploying, and maintaining the sensors. You need data scientists to be able to ingest these massive amounts of data to know how to process them and display them in a way that people can understand and interpret, whether that be through time series plots, correlation plots, a pie chart, a calendar chart. That's a very handy graphic that we found in our experience, that really resonates with people. You can have all these, detailed time series and numbers and stuff, but if you just put a calendar plot, like the month of January, and it has, days 1 through 31, and then you just color code each day by the daily average of the pollution, that's a lot more easy to digest for people. So for example, you might see on July 1st, the PM 2.5 levels are extremely high, and then like the rest of the days it's like pretty clean. And then people can relate that and say, oh yeah, that was New Year's. That was when we were doing fireworks. I don't know if you guys do that here for New Year's. And then research assistant, you have a data scientist, right? But you've also got to have someone who's trained on the air quality issues, who understands the basics of air pollution, what the health impacts are of each of those pollutants. Someone who's able to ask kind of these curiosity questions and make these linkages between this information we're getting from the monitors versus what it might mean for the community or for the health. And then finally, there should be someone who can play this outreach manager role, because whenever you're doing a community monitoring project, it's not enough to have brilliant scientists and money and sensors and stuff like that. You've got to have buy-in from the community, someone who can connect with the members so that they can feel comfortable having someone kind of invade their space, putting devices there, tracking the air quality, making them feel like there's a good reason for the sensors to be there, why this project would benefit them in any way. Okay, finally, you get to choose a sensor after you've taken all these planning steps. So, when you're choosing your sensor, you want to think about, how can the data be accessed or visualized? Because again, a lot of these sensor companies, they're going towards a subscription model, and they want to charge you to, get your own data. So you can go that route, but that means more of your budget has to go towards paying them these subscription fees, right? Is the data public or private? Some communities, they're not comfortable with, like, for example, the purple air model, where it's like all the data is on the map, public, and everyone can see it. Some communities, they're more private. They don't want that information for everyone. They just want that information for them to view. And then finally, you've got to, on the technical side, you've got to make sure the sensor meets the needs of the project. So, one resource is the manufacturer spec sheets. They'll tell you, what is the minimum concentration level their sensor will work at, what is the maximum, what temperatures and what humidities will work at, what is their claimed accuracy. But you might also want to double check them on that. Maybe take a look at the scientific literature. There's a lot of great scientists in the field who do evaluations and testing of the sensors that can provide more independent kind of pictures of how these products actually perform. And then finally, I want to point out AQ-Spec test reports. So the Air Quality Sensor Performance Evaluation Center, that's the program that I run, and we publish these test reports about all these different kinds of sensors that we've tested in the field, in the laboratory, and I'll be talking about that tomorrow. But you should definitely use as many resources as you can to really make sure that before you commit money to buying a sensor, it's going to do most of the things that you need it to do for your project to be a success. Oh, that's just the same thing. More pictures. Yeah, think about the sensors, think about the housing and the weatherproof. All right. So another part of planning for quality is training. That's standardization. So you want to make sure that all the people that are involved in this project, they're all on the same page. You don't have different actors doing this with the sensor and installing it another way and analyzing the data a different way. So training of all the people involved in the project, keeping good documentation and records, having consistent sensor setup and installation practices, having consistent sensor maintenance practices, and also having consistent ways that you treat the data and the metadata. So the metadata is kind of not just the PM 2.5 value and the timestamp. It's kind of the data about the site, the location, when was it installed, what is the make and the model number, what's the firmware number, what's the serial number. Because although that may not sound so important, later on if there's issues with the data or there's questions that come up, the metadata can be very helpful in seeing if that data is usable or not. Now for confidence in the data, there are a lot of good practices you can take for ensuring high quality. First and foremost is calibration. You might want to also have replicates, multiples of that sensor if you can afford it, because it's good to have them as backups or as sensors to check on another one, because maybe if you have 3 of them and one of them is different from the other 2, that gives you an indication of which sensor might not be good to include in your project anymore. You also want to have extra sensors to keep track of background level measurements. So perhaps you might want to site a couple sensors in a cleaner region to kind of monitor that drift of that sensor. And then you can, if you keep track of that drift, perhaps you can use that drift that you see in a background site to correct and adjust for the ones that you're having downstream of your pollutant source to get a more accurate picture. And then finally, you want to have some data review and validation procedures. So this means having kind of a protocol of, okay, when the raw data comes in, what are some first level checks or some first level processes to eliminate questionable data, and then other standardized practices to perhaps adjust some data to make the analysis and the results more usable. Okay, so the path to sensor deployment. Yes, it is tempting to go ahead and buy sensors and stick them on the field, right? But you should think about, let's do some initial setup steps, do some calibration, and then we can get to deployment. And then even after deployment, you have to still maintain them to keep them, reporting high quality data before, you continue to deploy them. So for initial sensor setup, it's good to do what's called bench testing. So obviously check that it powers on and that the data is indeed being stored or logged or transmitted. And also allow for whatever manufactured specified time for the sensor to warm up. So for particulate matter sensors, this is typically within a matter of seconds. But for gas sensors, some manufacturers are telling you, oh, let it sit for like 1 or 2 weeks to condition the local environment before the data is usable. Or that they're actually working in orange next to one of these PM sensors, and you should expect that there will be some kind of nominal response to that activity. For gas sensors, it really depends on the pollutant. So for NO2 and carbon monoxide sensors, you might want to bring it near like a gas stove burner or near a car tailpipe to check that it's showing something. For ozone sensors, if you have like a laser printer or a copy machine, maybe just like have it next to that and see that it's picking up some ozone. If you have CO2 sensors, just breathe on it. And for VOC sensors, hand sanitizers, perfumes, maybe open the gas tank on your car, see if it responds to that. And another part for bench testing is kind of removing the bad eggs. In every batch of sensors, there might be a few of them that aren't quite good. So, you want to identify the bad ones, so let them co-locate with each other for a few days. So let them run, and then look at the distributions of their measurements. And then see if there are sensors in the group that their distributions are pretty different from the others. So here's an example. This is not real, this is made up, but here's an example of like 6 PM 2.5 sensors and their distributions. So if I had to figure out which of these sensors should I keep to use for the monitoring project, and which sensors should I kind of not use because their response is very different from the others, which ones do you think I should keep and which ones should I not use?